Boeing has once again made headlines with an excellent innovation. The aviation giant recently unveiled an advanced supersonic jet designed to revolutionize the skies. Packed with advanced features, this sleek marvel promises faster speeds, enhanced fuel efficiency, and unparalleled performance. But is this technological powerhouse truly ready to dominate the skies? What unique capabilities make it a game-changer? Join us as we unveil an advanced technological marvel, Boeing's tiny supersonic jet that is ready for battle. Finally, the United States Air Force is preparing to welcome its newest advanced trainer jet, the T-7A Red Hawk, an advanced aircraft built by Boeing. This remarkable jet recently passed 3 major tests to prove its performance and reliability. These included harsh climate testing, escape system evaluations, and software trials that allowed it to reach an impressive 25-degree angle of attack. Boeing's Vice President and T-7 Program Manager, Evelyn Moore, shared that flight and escape system testing will continue into 2025, ensuring the Red Hawk meets all expectations. This next-generation trainer replaces the decades-old T-38 Talon and boasts innovative features that set it apart. The T-38 Talon was the backbone of the United States Air Force pilot training programs. Introduced in 1959, the T-38 was the world's first supersonic jet trainer and remains in service today due to its reliability and adaptability. Powered by twin General Electric J85-5A afterburning turbojet engines, the T-38 can reach speeds of Mach 1.3, a performance level comparable to some contemporary fighter jets. Over the decades, the T-38 has been used for various roles beyond pilot training, including reconnaissance, test pilot preparation, and astronaut training for NASA. It has undergone numerous upgrades to maintain its operational effectiveness, including avionics enhancements, structural reinforcements, and engine improvements. These updates have extended the aircraft's service life, though the T-7A will eventually replace it at many training facilities. It also holds a special place in aviation history as the aircraft of choice for the Thunderbirds, the United States Air Force's precision aerobatics team, from 1974 to 1982. During this time, the Thunderbirds performed very complex maneuvers at air shows across the country, showcasing its capabilities while inspiring new generations of aviators. Training naval aviators presents unique challenges, particularly the complexities of carrier-based operations. Pilots must learn to take off and land on aircraft carriers, requiring extraordinary precision and adaptability. Carrier landings involve catching an arresting wire with a tail hook to decelerate rapidly, while takeoffs often require catapult-assisted launches. These demanding procedures are practiced extensively on land before pilots attempt them at sea. The McDonnell Douglas T-45 Goshawk was introduced in 1988 to meet the specific needs of naval aviation. A derivative of the British BAE Systems Hawk, the T-45 is optimized for carrier-based operations and features robust landing gear, strengthened airframes, and advanced avionics. Its design allows it to simulate the handling characteristics of frontline Navy jets, like the F/A-18 Hornet, providing an invaluable training platform for naval pilots. It has received several upgrades over the years, including the T-45C variant, which features a glass cockpit with digital avionics systems similar to modern combat aircraft. Notably, the T-45C was also one of the first military aircraft to complete a biofuel flight, aligning with the Navy's Great Green Fleet initiative to reduce reliance on fossil fuels and promote environmental sustainability. In addition to traditional trainer aircraft, the U.S. military has embraced cutting-edge technologies to enhance pilot training. Programs like pilot training next integrate virtual reality, artificial intelligence, and other advanced tools to create immersive learning environments. These technologies complement the use of physical aircraft, allowing pilots to practice complex scenarios safely and cost-effectively. Specialized simulators replicate the performance of various aircraft, including the T-38 and T-7A, enabling pilots to familiarize themselves with different systems and flight conditions. This combined approach ensures that trainees develop a comprehensive skill set before transitioning to operational roles. As aviation technology continues to evolve, so does the pilot training approach. The introduction of the T-7A Red Hawk, combined with advancements in simulation and digital training tools, represents a significant leap forward in preparing pilots for the challenges of modern warfare. By updating trainer fleets and incorporating innovative methodologies, the military ensures that its aviators are equipped to handle any mission with confidence and precision. The idea of replacing the T-38 began as early as 2003, led by the USAF's Air Education and Training Command. At first, the plan was to have a replacement ready by 2020, but setbacks occurred due to shifting priorities and budget constraints. Tragically, a fatal crash in 2008 involving a T-38C showed the urgent need for a modern trainer, pushing the goal for initial operational capability to 2017. Despite delays and funding challenges, the project remained a top priority, and the program, later known as the TX competition, officially began. Boeing and Saab joined forces to compete for the TX program, unveiling their sleek, twin-tail design in September 2016. The prototype, powered by a General Electric FF404 afterburning turbofan engine that enables supersonic speeds, allowing pilots to practice high-speed maneuvers and operations, flew for the first time in December of the same year. The aircraft's design also incorporates features that mimic the cockpits and control systems of frontline fighter jets, ensuring a seamless transition for pilots moving to operational roles. By September 2018, the USAF announced that Boeing's proposal would lead the future of pilot training under a $9.2 billion contract for 351 aircraft, 46 simulators, and maintenance support. Additional options could increase the number of jets to 475. The project also came with financial challenges. In 2018, Boeing absorbed a $691 million pre-tax charge, partly due to the TX program. Saab decided in 2019 to establish a U.S. manufacturing facility in West Lafayette, Indiana to support production. This facility focuses on building critical sections of the T-7, such as the aft section and its subsystems, including hydraulics and fuel systems. The T-7 was officially named Red Hawk in September 2019 as a tribute to the legendary Tuskegee Airmen who flew red-tailed P-51 Mustangs during the Second World War. This naming also honors the Curtiss P-40 Warhawk, flown by the 99th Fighter Squadron, the first all-black fighter squadron in U.S. military history. Production of the T-7A began in February 2021, with Saab delivering the first aft sections to Boeing's St. Louis plant later that year. Advanced digital engineering played a vital role in the aircraft's development. This innovative approach allowed the T-7A to progress from concept to its first test flight in just 36 months. Using a digitized production line, the assembly process is highly efficient. For instance, splicing the aft section to the wings takes only 30 minutes. By April 2022, the first production, T-7, rolled off the line, marking a significant milestone. Despite its achievements, the T-7 program has faced challenges. In May 2023, the Government Accountability Office highlighted software and safety system delays, pushing the USAF's production decision to 2025. Nevertheless, Boeing aimed to start delivering operational T-7s by 2024. In June 2023, the first flight of a production T-7 took place, piloted by Major Bryce Turner and Boeing's chief test pilot, Steve Schmidt. By September 2023, the first T-7A Red Hawk was delivered to Edwards Air Force Base for testing, with additional test units later that year. The T-7's design emphasizes versatility and advanced capabilities. It is specifically engineered for high-G maneuvers, high angles of attack, and nighttime operations. The aircraft's GE F404 turbofan engine generates triple the thrust of its predecessor, the T-38, offering exceptional performance. Additionally, the T-7 is designed with future adaptability in mind, allowing it to take on roles like aggressor training or light attack missions. The Red Hawk also offers advanced training tools. It integrates live, virtual, and constructive or LVC environments to ensure cost-effective and immersive training for future fighter and bomber pilots. High-resolution simulators and ground-based systems make the experience realistic and robust. The jet's striking red tail is a tribute to the Tuskegee Airmen, the heroic African-American pilots who flew red-tailed fighters in the Second World War. Their legacy lives on in this state-of-the-art aircraft. In January 2024, Boeing enlisted Swedish aerospace company Saab to supply aft fuselages in a $101.20 million deal, adding international expertise to the program. Testing has been rigorous. One of the prototypes, APT-3, endured extreme temperatures from -25 degrees Fahrenheit to 110 degrees Fahrenheit at Eglin Air Force Base, Florida, to confirm its durability in tough conditions. Back in St. Louis, the aircraft is undergoing further evaluations. Boeing also conducted sled tests in New Mexico to refine the escape system, focusing on a safer ejection seat and canopy design. The improvements aim to minimize pilot injuries during emergencies. Additionally, the aircraft demonstrated its advanced software capabilities. Recent flights showed the Red Hawk's precise control at high angles of attack, a crucial skill for pilot training. These successful tests paved the way for further evaluations at Edwards Air Force Base. Boeing's recent tests of the Red Hawk not only enhanced the aircraft's safety features and showcased its advanced software capabilities, ensuring a safer and more effective training platform for future pilots. This aligns with the rigorous journey of becoming a military pilot, which requires extensive training both in simulators and in the air. By combining advanced technology with thorough preparation, programs like these ensure pilots are equipped to handle both basic maneuvers and complex combat scenarios. No simulation can entirely replicate the experience of flying a real aircraft, a challenge that has shaped the development of trainer aircraft for nearly a century. Since their inception, trainer aircraft have been fundamental to the success of military aviation programs. They provide an essential bridge between classroom instruction and real-world flying, allowing pilots to gain confidence and proficiency in the air. In the early years, the United States military relied on aircraft like the iconic P-51 Mustang to train new pilots. Known for its versatility and performance, the P-51 played a dual role as both a combat aircraft and a trainer, with specialized two-seat versions designed to teach advanced flight techniques, combat strategies, and weapon systems operation. As the P-51 aged, it transitioned to a new role as a historical and ceremonial aircraft. Today, restored P-51 Mustangs are frequently showcased in air shows, where they pay tribute to the legendary Tuskegee Airmen, the first all-black fighter squadron in U.S. history. The Tuskegee Airmen's red-tailed plane became symbols of courage and skill, inspiring a new generation of aviators and laying the groundwork for modern trainer aircraft programs. Moving on, Boeing aims to deliver over 2,700 Red Hawks to air forces worldwide, and the U.S. military is exploring the possibility of weaponizing the T-7A to replace aging platforms like the F-16 Fighting Falcon. Recent news from Tokyo reveals that Japan is considering the Boeing Saab T-7A Red Hawk, or a similar version, as its next-generation jet trainer. The Japan Air Self-Defense Force is interested in replacing its current Kawasaki T-4 with the same model the U.S. Air Force used. This choice would save costs and increase compatibility between the two allies. According to the Mainichi Shimbun, Japan and the U.S. are already working together to develop this new trainer. Prime Minister Fumio Kishida was expected to visit Washington on April 10 to sign an agreement. If finalized, this collaboration would mark the first time the two nations have jointly developed a training aircraft. The project aims to cut production costs while strengthening military ties between the countries. Other countries, including Australia and Serbia, have also shown interest in the T-7. However, delays in the program caused Australia to postpone replacing its BAE Hawk trainers, and Serbia's potential interest lies in a light fighter version still in the concept phase. Despite these delays, the T-7 remains a strong contender for global markets, offering advanced capabilities and cost-effectiveness. When asked about the report, a Boeing spokesperson told the War Zone that Boeing has a long history of supporting Japan's strategic needs and remains committed to working with the Japanese government as its defense requirements evolve. The Japan Air Self-Defense Force needs a new aircraft to replace its T-4 advanced jet trainers, which have been in service for decades. The T-4 first flew in 1985 as a prototype and officially entered service in 1988. Over 200 units were built, with over 180 still in use today. However, the fleet has faced challenges recently, particularly after an engine problem was discovered in 2019. The T-4 is used not only for training, but also for liaison and test work, and it is the aircraft of choice for the JASDF's Blue Impulse aerobatic demonstration team. Though the T-4 performs well at subsonic speeds, it's considered an intermediate trainer, It was designed to replace older jets like the Lockheed T-33 and Fuji T-1 and to take on some of the faster Mitsubishi T-2 training roles. However, the T-4 is starting to show its age. It's no longer suitable for training the next generation of JASDF pilots, especially those who will go on to fly advanced aircraft like the F-35 stealth fighter and eventually the new sixth-generation fighters being developed under the GCAP, or Global Combat Air Program, with the United Kingdom and Japan. An official artist concept of a future GCAP fighter, with Mount Fuji in the background, shows how advanced Japan's future fleet will be. The JASDF relies on two-seat versions of the Mitsubishi F-2 and F-15J fighters for advanced training to keep up with these changes. However, these aircraft are costly, and the T-7 could offer a more affordable solution. It and other advanced trainers could take on much of the tactical training these high-performance fighters currently handle. This would save the JASDF money while providing top-notch training for future pilots. Working with the United States on the T-7 could offer Japan several key benefits. By joining a program with an established production line, Japan could lower costs while ensuring a steady supply of spare parts and access to maintenance hubs. This is particularly important since supporting the older T-4, which stopped production years ago and was never exported, has sometimes been challenging due to unreliable spare parts. With growing concerns over a potential conflict with China, Japan is focused on strengthening its defense supply chains. This focus was highlighted during the Japan-U.S. Economic Policy Consultative Committee meeting last November, where both nations agreed on the need for more resilient defense partnerships. Japan is also excited about the possibility of deeper collaboration with the U.S. to develop cutting-edge technologies, especially in artificial intelligence. As AI becomes a key part of aircrew training, Japan hopes to use it not only for training, but also to advance its future fleet of uncrewed aircraft, which will work alongside the GCAP program. Japan and the U.S. signed an agreement last December to jointly research AI technologies for drones, aiming to stay at the forefront of military innovation. There are no clear signs that Japan plans to assemble the T-7 locally, as it has done with the F-35. Instead, Japan seems focused on cutting costs by taking advantage of the Red Hawk's efficiency of mass production. This approach would allow Japan to benefit from the economies of scale already built into the program. However, it's still possible that Japan could participate in the broader production effort for the T-7, even if it's not involved in assembling the aircraft itself. Japanese companies could potentially contribute to certain components or systems, which would allow them to be involved in the program while still relying on the established production lines in the U.S. for Boeing and the T-7 program. Having Japan place an order or become more deeply involved in the production effort would be a significant boost. The T-7 program has faced several challenges, including technical issues and delays, which have been widely reported. These difficulties have caused some uncertainty around the program, and having a large international customer like Japan could help stabilize the situation. It would signal that the aircraft is still viable despite its setbacks. The U.S. Air Force's 2025 budget proposal has revealed some concerning news for the T-7 program. The Air Force has cut the planned purchase of T-7s by half, reducing it to just 7 aircraft for $235 million. This decision is partly due to budget constraints, but also reflects the ongoing uncertainty surrounding the aircraft's development. The program delays and concerns over its readiness have led to questions about whether the T-7 will meet the Air Force's needs in time. According to the budget documents, the developmental testing and evaluation phase of the T-7 is expected to be completed by May 2025, and the start of initial operational test and evaluation is planned for January 2026. The first low-rate initial production deliveries are expected to occur in April 2026, with the U.S. Air Force not anticipating initial operational capability until 2028. This represents a further delay, as earlier predictions had suggested IOC could be reached as soon as 2027. The program is clearly facing significant challenges, and T-7 is not expected to be fully operational for several more years than initially planned. Adding to the financial difficulties, Boeing has reported $1.3 billion in losses related to the T-7 program. The company had initially underbid during the TX competition to secure the contract, but has since been hit with costs due to delays and technical challenges. This financial strain highlights how tough things have been for Boeing as it works to bring the T-7 to fruition. Despite these challenges, if Japan were to commit to the T-7 program, it would be a significant aircraft endorsement. A large-scale order from Japan would provide financial support for Boeing and demonstrate confidence in the T-7's future, potentially helping to stabilize the program and move it forward. Japan's involvement could be the turning point that boosts the T-7's prospects and secures its place in the future of military aviation. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.